How many of you have been on teams that struggled with testing? And how many of you have been on the receiving end of buggy software? In today's world, software testing affects us all. Over the years, I've had the privilege of leading several teams that were able to deliver extremely high quality and well-tested software. And I consistently found that the enabler to creating these test-infected teams was to make it easy to write comprehensive tests. Today, I'm super excited to share with you the recently open source Finatra library, which helped Twitter engineers write highly performant, high quality, and well-tested services. But before diving into the details, let's answer the question that's on many of your minds. The question of, what's with the weird name, Finatra? Well, there's a rationale behind the name, and the name is actually the combination of the names of two other popular libraries. The start of our name comes from the Finagle library, which is Twitter's library for writing highly concurrent RPC services on the JVM. Finatra is built on top of Finagle, and both are written in Scala, which is the primary language used for server-side development at Twitter. And Finagle is not just used at Twitter. And on screen, you can see a sampling of other companies that are using Finagle. The end of our name comes from the popular Ruby library named Sinatra, which defines a simple DSL for writing web applications. Now, Finatra does not share any code with Sinatra, but we do share their philosophies of elegance and minimalism. So there you have it. You take the high-performance Finagle library and the elegant minimalism of the Sinatra library, put them together, and you get Finatra, which makes building applications on top of Twitter's open source stack an absolute joy. I'm really excited to showcase some of Finatra's features and motivations with you today. Finatra version 1 started in 2012 as a side project from two Twitter engineers. It was developed on GitHub first, and it quickly gained a following due to its simplicity and customer focus. In 2013, my coworker Chris Coco and I started work productizing an API for some key enterprise partners. API testability was a major concern for us, and we needed to write some additional tools to make it easier to write the types of tests that we wanted. We became the Finatra v2 maintainers and worked on redesigning it from the ground up. Next year, in 2014, we launched Finatra v2 internally at Twitter for other projects to use. And we then started work open sourcing version 2, which we spent our next couple hack weeks on. That culminated in April of this year when we released our first milestone to GitHub. And then a couple months later, we were delighted to find out that Finatra v2 was chosen as Twitter's production HTTP framework for all new services. And just last month, we released the first non-milestone full version 2 of Finatra to both GitHub and Maven Central. Daily Finatra development happens in Twitter's Git repo, and we push all changes weekly to GitHub. We're developed under the Apache 2 license, and we take pull requests from the entire community. OK, so I'd now like to discuss three main topics related to Finatra, with the first of them being feature testing. So what is a feature test? A feature test is the name we've given to a style of testing we've found to be particularly valuable. It combines elements of integration testing and in-process and out-of-process component testing. We limit the scope of the system under test using testables, usually in place of external components. And typically, a feature test is one-to-one with a customer-facing feature, such as creating a user by sending a post request to a certain URI. A feature test primarily acts as a black box test, where it issues HTTP requests and asserts the responses. However, a feature test is also free to be white box and assert internal class state. Note, a feature test is not an end-to-end test, as we use testables in place of external components. And this is really important for making sure a feature test remains fast and non-flaky. OK, so given a choice now between writing a feature test and a more traditional unit or integration test, which one do you write first? And for my team, the answer is clear. If you're developing a new customer-facing feature, you always write a feature test first. And if you're following test-driven development, this is ideal, because it's super simple to create a failing compiling test using a feature test without writing a single line of production code. Finatra makes it easy to write API feature tests such as these. And my team is not the only one that has a feature test first approach to software testing. The current deputy CTO of TypeSafe, which is the company behind Scala, had this to say when he was the tech lead of the popular Akka project. In our test philosophy, a feature test is something we must have. It's a test that verifies that something we want to build works and works as expected. If you don't have a feature test, you might not even have a feature. So now you may be wondering, what does this feature test look like? And on screen, you could see one. So in this example, we're creating a feature test for an HTTP service. So we'll use an embedded HTTP server to wrap our server, in this case, a popular API server. In the test, we'll then call the HTTP post method, specify the path, the post body, specify we expect an OK to be returned, and then inline the JSON body that we expect. It's that simple. So next, let's look at some of the qualities any good test should possess. First, any good test should be fast. Otherwise, you won't be able to run it continuously when writing new code. Second, tests must be non-flaky. Otherwise, they'll fail intermittently, you won't trust them, and they'll cause unnecessary churn every time one fails. Next, a good test has to actually catch bugs, which means you're writing good assertions in the right places. And finally, a good test needs to be easy to write and easy to maintain. Otherwise, you won't write enough of them, and your test coverage will suffer. Finatra provides the tools to make writing feature tests that satisfy all of these qualities. And my team believes that when you satisfy all of these qualities, feature tests can be run continuously when you're doing any new development. Large-scale refactorings become an absolute joy as customer-facing regressions are immediately detected. And feature tests are extremely non-brittle. So when you refactor your code, a feature test rarely needs to change. OK, so now for a real-world example. My team is responsible for GNIP's engagement API, which was just announced at Flight today. We're super excited. On screen at the top, you could see our test suite running against the API. It's comprised almost entirely of feature tests, and the 88 tests run in only 7 seconds. On the bottom of the screen, you can see the test coverage we're able to achieve with this test suite, 99.6% statement level coverage. A couple things worth noting. First, test coverage means nothing if you're not asserting the right things and it's a bad test. However, a high test coverage is a prerequisite for any good test suite hoping to catch bugs before they hit production. Second, these feature tests are higher level than a unit test. However, because they run fast, you can run them continuously when writing new code. And this mitigates many of the cons often associated with higher level tests, which you can only run periodically throughout the day. OK, so we've discussed feature testing. Now on to the second main topic, and that's dependency injection frameworks. So as many in the audience know, dependency injection is simply a design pattern that seeks to decouple a class from the creation or lookup of its dependencies. And dependency injection makes it easy to unit test classes. Therefore, you'll see it as a common pattern in various programming languages. And since it's only a design pattern, it can be done manually. So you may be asking yourself, why do we need a framework? And for that, let me introduce you to dependency injection's arch nemesis, boilerplate. Boilerplate is the sections of code that have to be included in many places with little or no alteration. And in the words of Joshua Block, boilerplate is ugly, annoying, and error-prone. So what can we do about it? One thing is we can enlist the help of a dependency injection framework. These frameworks help eliminate boilerplate involving object construction throughout your server. They also provide a consistent methodology for configuring your classes. Finally, they facilitate seamless integration and feature testing by making it easy to swap in test doubles in various places of your application. Now, quick side note, dependency injection support in Finatra is strictly optional. So if you choose not to use it, you're free to manually create your classes or use other techniques. However, we've found great value in using it. OK. Along those lines, the Finatra project is not the only Scala library to adopt the dependency injection framework, primarily for the purposes of testing. And the Play framework, a popular Scala and Java framework on the JVM, their tech lead had this to say when they adopted a DI framework for testing. The main advantage that dependency injection brings is not realized until you start writing tests. Once you move on to integration testing, this is where Play can start to realize the advantages of DI. So once we decided that we wanted to include dependency injection support out of the box, if you choose to use it, we had to decide on an implementation. And after evaluating the various choices available to us, we decided on JSR 330, which defines some simple annotations that can be used in any JVM language. We then picked as our implementation Google Juice for its popularity, simplicity, and maturity. So on screen, you could see what this JSR 330 dependency injection annotations look like. At the top of the screen, there's an @singleton. That signals to Finatra and Juice that we only want a single controller to ever be created. And on the line below it, you'll see an @inject. This signals that we wish for this class to participate in dependency injection. So when it's created, we want its dependencies to also be given to it. And it's that simple. So now let's look at how we would add that controller to our server. In this case, we're an HTTP server, so we'll extend the HTTP server class. We'll then provide a list of Juice modules for some of the classes we wish to inject. And then we override the configure HTTP method. We specify filters, and we specify controllers that we wish to serve. Note that there's zero boilerplate in adding the filters and controllers. You simply specify the type of the filter and the type of the controller, and Finatra and Juice handles creating those classes and creating the dependencies. We let Juice do the heavy lifting, and it eliminates a lot of boilerplate. As mentioned earlier, dependency injection frameworks also facilitate integration and feature testing. And on screen, you could see a feature test that takes advantage of Juice's support for swapping in testables. Under the bind mocks comment, you'll see our use of the @bind annotation. That signals to Juice that we wish to swap out a real class with a testable. And in this case, it's a Mockito-created mock. And underneath the setup mocks comment, you'll see where we script up the mocks to return the desired behavior at the desired times. OK, so now on to the third topic, consistency. Finatra enables a common look and feel across a spectrum of applications. And this extends anywhere from a command line application to a long-running server, let's say listening from a message queue, to an HTTP server, to a Thrift server. To demonstrate this consistency, on screen, you could see how you would create a Thrift service using Finatra. Notice that we now extend Thrift server instead of HTTP server. The list of modules is the same. We could share Juice modules across different types of services. And now we override configure Thrift, where again, we add filters and we add the Thrift service we wish to serve. The consistency is so great that we can even create a server that's both HTTP and Thrift. And on screen, you can see a demonstration of that. Notice we supply our modules and then override both configure methods. And we're even able to reuse some of the same filters across both. Now, you may be asking yourself, why would a server want to be both? Well, we have several teams at Twitter that maintain production Thrift services, but they also wanted to create a UI on top of it to access some of the state. Before Finatra, they had to learn two completely different frameworks for configuring their servers. But with Finatra, there's one consistent way. Consistency also applies to feature testing. So on screen, you could see how we feature test a Thrift server. Again, very similar. We now have an embedded Thrift server instead of an embedded HTTP server, but otherwise the same look and feel. Consistency also applies across both Java and Scala. And on screen, you could see how we create a Java-based HTTP server. Now, the Java syntax, of course, a little bit different than the Scala syntax, but basic look and feel. You supply your Juice modules. You override the configure HTTP method, add your filter, add your controller. In addition, controllers can have a consistent look and feel, especially if you're able to use Java 8's new Lambda syntax. On the top of the screen, a controller written in Scala. And on the bottom of the screen, the same exact controller written in Java. OK, so after working through feature testing, dependency injection frameworks, and consistency, let's walk through an end-to-end example to see how all the pieces fit together. And for this example, we'll create an API that returns a user's most popular tweets in a given time range. We'll call this API the Popular Tweets API, and we'll define popularity based on the number of impressions and the number of engagements a tweet has gotten. The requirements from your product manager are as follows. Handle a post request to /API/popular. An API key will be set in a header. The request is going to contain a JSON body containing a start and end field in ISO 8601 format. If the request is valid, return a 200 OK response. The response is going to contain JSON, return the start, the end, and the tweets in popularity order. So now that we have our requirements, let's write a feature test. Pretty simple. First, we have a server. Now, we haven't written any production code yet. So for now, we just use a blank HTTP server. We'll fill that in later. We then specify the path, the headers, the post body. We expect an OK. And here's the JSON we expect. When we run that test, it fails, expectedly. We haven't written any production code yet. However, we now have a comprehensive test that we could use throughout the implementation of this feature. OK, let's begin by parsing the request. Finatra's approach to parsing JSON is to create a class that mimics the structure of the JSON we wish to parse. So on the left, you could see the start and the end field in JSON. And on the right, you could see the class. There's a start field. It's a date time. There's an end field. There's a date time. Now, notice to the left, there's an @pasttime annotation. This is a validation annotation, which signals to Finatra that these times need to occur in the past. After all, it wouldn't make much sense if they were in the future. On the line below that, you'll see an API key field annotated with @header. This indicates this field is going to come from the request header. And there's a not empty annotation, which means the header cannot be an empty string. It has to actually be populated. Now that we've handled parsing a request, let's generate a response. Same concept as parsing the request. We make a class mimicking the JSON we'd like to generate. So you'll notice we have a start that's at datetime, an end that's a datetime, and tweets is a sequence of tweets. All right. Now let's look at how we're going to get the data for this API. And we're going to use two of GNIP's new APIs, one from earlier this year, and the other was just released today. So first, we'll use the full archive search API. It, among other things, will let us get the user's tweets for a given time period. We'll then use the engagement API, given a tweet ID, to look up the number of impressions and the number of engagements that tweet has received. OK, so now let's look at what our controller would look like calling these services. First, we annotate with @singleton, again indicating we only want one instance of this controller to be created. We then have @inject, indicating we wish for the dependencies of this class to be populated. In the middle of the class, you'll see Sinatra-style routing, where there's an HTTP post method and then the path we wish to handle. In this case, /API/popular. Inside the post request, or inside the post method is a callback. The callback has a request. The request is the custom request we just created. It knows how to parse our JSON and our header. Then in the middle of the callback, you'll see Finagle's elegant handling of non-blocking operations. So if you notice, the user repository, that's going to call an external database. The search service is going to call the full archive search API. The engagement service is going to call the remote engagement API. All three of these calls are asynchronous. However, we're able to elegantly chain those together using Finagle's support for futures and for comprehensions. It's really nice. OK, if all three of those succeed, we then yield an API response. That API response will then be turned into the JSON we wish to generate. Let's now add that controller to our server. We list our modules. We have a configure HTTP method. We list the common set of filters that most services will want. And then we add the popular controller by type. Now that we have a real server, we can add that to our feature test instead of the blank HTTP server. And now we could run that test again. But it fails. But this time for another reason. This time it fails, and Finagle tells us it failed because a resolver was not found. The error is a bit cryptic, but basically what it's saying is Finagle tried to connect to a remote service, but we didn't tell Finagle where that remote service was. To fix this, we're going to need to use a testable in place of the real classes that are trying to call the external services. And you've seen this before. We simply use the @bind annotation in Juice. So we specify, instead of a real database client, a real search client, and a real engagement client, use mocks. Now when you run that test, success. And Finatra will print what the request and the response look like. OK, we've tested the happy path through our system. Let's write one additional test for an invalid request. For this test, our start field will not be a valid date. Our end field will be in the future. And we'll expect a bad request to be returned. When we run this test, also success. So Finatra has detected that this request is invalid because of the validation annotations we used. Notice that in addition to returning the 400 bad requests, we also got an error message accumulating all the different errors. So it didn't stop at the first error that the header was missing. It also tells us that the start was not a valid ISO 8601, and the end was not in the past. I've really enjoyed showing all of you how Finatra helps Twitter engineers write high-quality and well-tested services. We first looked at Finatra's support of feature tests, and we showed how they make writing comprehensive tests an absolute joy. Next, we looked at the built-in support for dependency injection and how it could eliminate boilerplate and make it easy to use test doubles in your feature tests. After that, we looked at consistency and how Finatra enables a consistent configuration and testing methodology that can be used across various application types. And finally, we looked at an end-to-end example that showed how some of these pieces are put together. For those of you in the audience that are able to pick up a new framework at work or for a side project at home, please visit our GitHub page, try out our examples, and provide us any feedback you may have. And for all of you out there, I'd encourage you to try a feature test approach to testing your software. It's worked for many of us at Twitter, and I think it also could work for many of you. Thank you.